All right, so read the problem and see if we can make some sense of this. So your company is going to make rectangular frames as part of a new product they're launching. The frame will be cut out of a piece of steel, and to keep the weight down, the final area, so the area of the face of this item should be 28 square centimeters. The inside of the frame has to be 11 centimeters by 6 centimeters. What should the width W of the metal be? Okay, and then typically, if you have a word problem and there's no diagram drawn, you want to start there. But here we have a diagram that's drawn for us to help us out. Although in the problem it said W, we see in the diagram there's an X, so we'll just put it in terms of X. And so we want to solve for that width. So I'm going to give you a couple minutes to think ahead of me, because eventually the goal is that you can do these without me. But I'm going to be helping you through this. But I want you to, in a couple minutes, try to figure out what you might do to solve for x. All right, is anybody coming up with an idea of how to start? Elijah? You found the area of the inside? So the inside area is what? So 6 times 11, 66. Okay, that might be helpful to us. Okay, so if you add the 66 plus the 28, what does that give you? The area of what? The large rectangle, right? So the area of the large rectangle is going to be 66 plus 28, which is 94. Okay, so that might be helpful to us. So just trying to make sense of what's given to us here. Still, we need to solve for x. Anybody else have an idea of where to go, to how to approach finding x? Yeah. Okay, so another expression for the area of the large rectangle is length times width, right? And we know that the length times the width is going to equal 94. And as Kaya was saying, well, the length here is going to be 11 plus 2x, because the inside white part's 11, but then you have that length x added on the left-hand side, and then you have that length x as well on the right-hand side. So 11 plus 2x would be the length of that larger rectangle. And in the same, with the same reasoning, the width would be 6 plus 2x. So now we can say that 11 plus 2x times 6 plus 2x is equal to 94. And that's what really we're working toward, some kind of equation that has the variable that we want to solve, which is x. And once we get there, then we don't need the word problem anymore, or the picture anymore. Now we can work straight from this. Okay, so I'm going to give you a little bit of time to try to solve for x now that we have an equation. So the first thing you want to do is clean up the equation. What I mean is multiply the 11 plus 2x times the 6 plus 2x. When you do that, you see that you have a quadratic, which is what our unit's on, right? We know it's quadratic because the highest power is 2 of x. And so then when you're solving a quadratic equation, you want to start by setting it equal to 0, putting it in order from highest power to lowest power. That's the best starting place because we have 3 methods to solve quadratic formula, which requires you to have it equal to 0 before you use the quadratic formula. Factoring, which also requires it to be equal to 0 before you factor, and then completing the square, which doesn't have to be equal to 0 to use that, but still a good idea to start like that. And then I noticed that all my numbers were even, so I just divided them all by 2 to work with smaller numbers. So now that we're at that spot, now we can pick one of our methods to solve for x. How many got to that far? Either of these. Okay. If you're on that, it's the right direction to go. So then we can check if it factors, because if it does, it might be a little less work for us. When we factor, remember we're looking for 2 numbers that multiply to a times c, so 2 times negative 14, and add to b, which would be 17. And well, 28 is 4 times 7, so that's 2 times 2 times 7 as its prime factorization. And we can make 4 and 7, which doesn't add to 17. Or we can do 2 and 14, which doesn't add to 17. Or we can do 1 and 28, and that still doesn't work. So if you can't figure this out and it doesn't work and you tried all possibilities, that tells us it does not factor. And not everything does. That's why we need the other methods. So what would you guys like to use? A quadratic formula or completing the square? I heard both, so do whatever you want, either of the two. Remember, you guys still have that quadratic formula memorized? Okay. You'll need that for the test, and you need to have that memorized for the test. So go ahead and use it and figure out how wide that frame should be. On the test, you will be able to use your calculator. Now here's my work. Okay. You get two answers. The plus or minus gives you two answers, but one of them you're going to throw out because in this context, it doesn't make sense to have a negative width. Okay. But it does make sense to have a 0.756 centimeter width. So there we go. Any questions on that one? So here's a problem about cutting metal, and didn't seem like it had anything to do with quadratics, but as we formed an equation, quadratics came out of out of nowhere, and we were able to apply our knowledge to this problem. All right, let's now take a look at number 68. Sorry, 58. So 58, we have the height of a baseball, t seconds after it's hit, is given by this function, negative 16t squared plus 64t plus 2. And we know that as things like balls travel through the air, they travel in the form of a parabola. And that's why we're getting that quadratic equation there. We want to find the maximum height that this baseball is going to go. We want to find out after how many seconds the ball will take to hit the ground, after it's hit. And then we want to also know what's the domain and the range of this particular function that's given to us. All right, so the actual function is quadratic, so we know it's going to make a parabolic shape. Okay, is it going to open up or down? Open, down, and it should, because baseball's going to travel like an upside down parabola, right? And we know that because a is negative here, right? So we got a is negative 16, and if a is negative, it makes it open down. So I'm going to just start with a little sketch here. Here's quadrant 1. And our x-axis is going to represent time, and our y-axis will represent the height of the ball. And what's our y-intercept going to be? 2. Okay. And it doesn't say what height is, but I'm just going to say let's work with feet, because actually that formula would be in feet. And so does it make sense that the ball would start at 2 feet above the ground? Why is that? When they hit it, right? It's pitched, the ball's pitched, and they're going to hit it. This one's about 2 feet above the ground when they hit it, so that's at t equals 0. And then it goes up in the air, and then it comes back down somewhere here. Okay. And so how do we find the maximum height that baseball will travel? Okay, so when you have a word problem, you hear the word maximum or the word minimum in the other context, you want to think, hey, that's a vertex problem. Okay, and here we need to find, if we can find the vertex, then we're going to find the maximum of that. Okay, so go ahead. You guys are experts now at doing this. Find that vertex and get an answer. Question to you is, what method are you using to get to that maximum? So you're actually solving for the vertex form? Okay, so that's one method. Most of you, though, as I'm looking around, are not using that method. Most of you are doing something else. What are you guys doing? the negative b over 2a to find the axis of symmetry, right? And then plugging that value in to get, and that's good too. So I'll show, we'll do both. So most of you guys are saying, okay, this halfway mark, the axis of symmetry, is happening when the time is at negative b over 2a, as that's the formula that we remembered. That's the quadratic formula without the square root part, okay? And when we plug in that, we get negative 64 over 2 times negative 16, which is negative 64 over negative 32, which is 2 seconds. So at 2 seconds, the ball is at its maximum height, and we've hit the middle. Does that mean it's going to land at 4 seconds? Can anybody tell me how high the ball is at 4 seconds without doing any hard work? It's 2 feet in the air. Good, because 2 seconds away from here, it's 2 feet in the air, right? On the left side, so 2 seconds on the right side, we have a point, not that we'll need it, but we know that at 4 seconds, it's going to be 2 feet in the air, which does tell us it's going to land after 4 seconds. Okay. So now we still want to reach that maximum height, so we could take our 2 seconds and plug it into our equation and find that y is going to be negative 16 times 2 squared plus 64 times 2 plus 2. And that's negative 64. And then 64 times 2, that's 64 plus 64 plus 2. So we're going to get 66. And that is our answer. Find the maximum height of the ball. It's going to be 66 feet. That's a nice hit, huh? Okay. Now that's one way to do it. Probably the quickest way to that answer. But there's another way. And another way to do this is to take our equation and to put it into another form, into vertex form. And you could kind of do a partial of each, like you can find this and then plug it into vertex form. But I just want us to go straight from that equation by, I want you to complete the square. Oh, sorry. I want you to go straight from the equation and complete the square. And just because we need to know how to do that for the test. We don't need it for this problem. We already have the answer. But pretend we haven't done any of this work. Go back to that standard form. See if you remember how to complete the square. And get that vertex form. Okay? So no formulas. When you complete the square, you're not allowed to use a formula. So solve by completing the square. Get that standard form into vertex form by completing the square. If you forget how to do that, you can look back at some of your notes. Fine with me. Okay, so maybe some of you did it. Some of you might be like, I don't remember how to do this, but here's what we do. So the first two terms, we need to factor a out of the first two terms. So a is negative 16, and so that would be our first step. And you factor out a negative 16, you get negative 16 times t squared minus 4t. And you have that plus 2 still on the outside. Then you want to focus on that t squared minus 4t. That is the part that you want to change into a perfect square. Okay, because when you think about vertex form, a is on the outside. We already put it on the outside. And then you have a perfect square here, and then whatever's left over here, it'll be in the form that we want, right? And so a little bit of scratch work here. If I have t squared minus 4t, what do I add to make that a perfect square? And t plus something squared. And what we do is we take the negative 4 here and do what to it? Divide it by 2. Cut it in half to get the minus 2. So that's what we want it to factor to. And so then we're going to take that minus 2 and do what to it to get this number? You square it. So in this case, negative 2 times negative 2 is positive 4. So we know we need to add 4, and then if we add 4, that will factor to a perfect square, t minus 2 times t minus 2. And so I'm ready to go back and finish this up. So I get y is equal to negative 16 t squared minus 4t. I'm going to add 4 to that. But if I add 4 on the inside, what do I have to do to balance the equation? So this 4 really has a value of negative 16 times 4. So by putting a 4 there, I've really subtracted 64. So what do I have to do to balance it? Add 64. So plus 16 times 4. Once we're there, we get y is negative 16, factors to t minus 2 squared. And then when we add all this up, we got 64 plus 2 gives us our 66. That's your vertex form with giving us a vertex of 2, 66, which is what we found already. But we just wanted to practice this because you will have a problem on your test that says, hey, there's your standard form. Put it in vertex form by completing the square, and your grade will not just be the answer, but it'll be the work leading to it. Okay? All right, so done with A. Part B, after how many seconds will the ball hit the ground? What is that asking for in x-intercept? Okay, so it's a root, a 0, x-intercept, solving the equation when you set y equal to 0. And we have 3 methods. I'm going to tell you factoring is not going to work. So that leaves 2 methods now. And since we've done all this work to complete the square, let's pick up from here and solve. Don't use a quadratic formula. Let's practice solving using that other method. So just set y equal to 0 and solve for t. To find out when it hits the ground. From our picture, we know we should get an answer greater than 4 seconds, right? So my work's in green here. I plugged in 0 for y, subtracted 66, divided by negative 16, double negative makes a positive. Take the square root, don't forget the plus or minus, add the 2, split it up, you get a positive answer and a negative answer. Throw out the negative answer because it's not going to make sense in our context. 4.03 does make sense. It'd be right after 4 seconds. So 4.03 seconds is a good estimate. So I know these are big problems, but they're bringing out a lot of stuff that we need to remember. All the kinds of solving, good rich problems here. We got one more question on this problem, and that's what is the domain and the range of the function that they give us? Okay, and we'll start with the domain. And let's go over, like, again, what is domain? Domain is what values can we plug into this function? And in this, when you have a word problem, what values would make sense to plug into that equation? Okay, so we know if we didn't have a context, answer would be all real numbers, because you can plug in anything into a quadratic equation. But in this context, talking about a ball going through the air and time and height, domain talks about what? Time or height? Time. Deals with your x variable. And so what times would make sense to plug into this equation? From what to what? 0 to 4.03. Okay? Those are the only times that would make sense with our equation. Could we plug in another number? Yes, but it wouldn't make sense. If I plug in a negative number, it's not going to be helpful. It's going to say the ball's behind the batter, which is not false. It's just false, right? If I'm going to plug in something past 4.03, that means it'll tell us that the ball's underground, which is not going to be helpful either, right? So the equation is only good for those times. After those times, it's not good at modeling the situation, okay? Now, a range is this. If I plug in any value between 0 and 4.03, what answers will I get? From what to what? That's what your range is. Your range is like, what's my lowest value as an answer that I'll get, and what's the highest value I'll get as an answer. And looking at a graph is the best way to do that. So looking at our graph, this is the only piece. What's the lowest value you see, and what's the highest value? 0 is the lowest, right? Hits ground level. We're not going to allow it to go underground. And the highest would be 66 feet. Okay. And so for our range, 0 less than or equal to y less than or equal to 66. So very different than what we did out of context. So you're going to have to, when you have word problems, you're going to have to think a little bit more about the domain and the range. Okay. Any questions on this one? All right, we've done 2 problems together. I promised you 3, so we're going to do one more with 57. So 57, you have a treasure hunting expedition. I wonder what kind of treasure they're hunting. Okay, and they're trying to have a successful mission and to minimize their cost. So what would a successful mission be? Find the treasure. Yes, nobody breaks a leg. Everybody's safe and happy. And you want to minimize its cost. And so these expeditions. So say you're a company, and you have to hire maybe an expert to do this. You have to pay for transportation, maybe rent the land, or I don't know. You have expenses, right? Um, but then you sell this to people, and you take them as a group. And if only one person signs up, you're probably not going to make that much money, right? Um, so you want to have, and if too many people sign up, then there's going to be issues and um, more costs for food and other supplies, and it may not be a good thing. So you want to find that exactly how many people should we have on this expedition to maximize our profit, because we want to make money as a business, right? That's kind of the idea where this is coming from. So the costs C in thousands of dollars are given by this function. So somehow they determine this function of really how much it's going to cost us at the end, after where X is the number of people involved in the expedition. So A says, what's the cost with 3 people? So go ahead and find that cost with 3 people. And so what's the cost going to be? 19,000. Good. You end up with 19, but you got to interpret that as thousands. So here's my work. You plug in 3 in for X, and you follow order of operations to get 19. And then you got to read that in context and say, well, that represents $19,000. Okay. All right, so B, what is the number of people associated with a successful mission and minimizing the cost of this expedition? So what is that asking us to do, or what are we going to have to do or find to answer B? Vertex. What gives that away? How do you know it's vertex? Minimizing, okay? Because if we graph this parabola here, we know it would open up, and it's already in vertex form, so we don't have much work to find the vertex. What is our vertex? 6, 1. All right, so what's the answer to B? Read it carefully. What is the number of people? So does our x variable represent people or a y variable? X. So how many people? 6 people. So if we get 6 people on this expedition, we minimize our cost. And what will that minimum cost be with a successful mission? What is that? $1,000. Good. All right. Now, lastly, we need to answer what's the domain of this function. What would you say it is? Be careful. Think about the context before you jump to a conclusion. Is it all real numbers? No. Is it all positive numbers? 1/2? 1/2 would not make sense. 0.37 would not make sense. Because we're talking about people here. So all positive whole numbers or all positive integers, that's what our domain would be. Those are the only numbers that make sense to plug into this equation because we're talking about people here, right? So domain is all positive integers. Now there might be a cap on that. We don't have enough information. I'm sure there is a cap on that, but right now, based on what we have, we'll say all positive integers. And then if we plug in positive integers, what would our range be? What's the lowest? 1,000. That's the minimum, right? And then anything above, right? So our range would be 1,000 above. So y is greater than or equal to $1,000. All right, so I worked through 3 problems with you. You have 6 more to do, and you have about an hour.